So we're in this next lesson. We're doing basic arithmetic operations. So we're going to add, subtract, multiply, and divide. We're going to go through a few definitions as well. So for example, we're going to start with adding. And when you're adding, of course, you add two numbers. 5 plus 3 gives you 8. Well, the different parts of that problem, the numbers that are being added are called addends, and then the sum, of course, is the total. And so 5 plus 3 would give you 8. So if I asked you in a problem, what is 5 called, it would be an addend, and what is 8 called, it would be the sum. Okay, the next little part that you have are your properties of addition. And the first one is closure. And closure is actually something that we use a lot in our upper level maths, like even in my master's level maths, we talked about closure a lot. But the other ones are more of what you'll do in an elementary school curriculum. So talking about closure for a second, it says if A and B are whole numbers, then A plus B is also a whole number. So what that means is if I add 5 and 3, 5's a whole number and 3's a whole number, and when I add them together, I get another whole number. So if I add these up, I get 8. So 5's a whole number, 3 is a whole number. When I put them together, I get a whole number. Let me show you something that's not closed, just for example. Let's say that you had 5, and that's an odd number. And I added that to 3, which is also an odd number. What I get back from that is 8. 8 is not an odd number. So this set, if you were talking about only the odd values are not closed under addition, because if I add an odd and an odd, I don't get an odd back. And so that gives you an example of what I mean by not closed. Going back to the original part though, it says closure, and we're talking about only whole numbers, odd and even. If you add two whole numbers, you get a whole number back, and that's what closure means. Okay, the next one is called commutative. A plus B equals B plus A. Okay, so let's talk about that with numbers we like. If I add 3 plus 2, I get 5. That's also the same thing as if I add 2 plus 3. So 2 plus 3 is 5 and 3 plus 2 is 5. It doesn't matter the ordering. It doesn't matter which one comes first. And so that's an example of commutative. Associative is grouped. See how the associative property has three things, A and B and C? It doesn't matter if you add A and B first or if you add B and C first, you're still going to get the same answer. So let's say that I took 5 plus 1 plus 4. Let's say over here I added these two first. So I'm going to get 6 plus 4, so I'm going to get 10. But let's say over here I added these two first. That's 5. 5 plus 5 is also 10. So it doesn't matter if I do the first group, 5 plus 1 first, or the second group, 1 plus 4 first. I'm going to get the same value. Lastly, you have an additive identity. Think about identity for a minute. Identity means that it's the same one. So like if you had a stolen identity. Somebody took your identity. So if I take A and I add it to the number 0, I get back the original term. And that's what's called an additive identity. And 0 will always be used in additive identities. Okay, so that's our first little group. They're going to ask you to add on a number line, and this is really good for students, especially the lower grade students. So if I ask you to add 4 plus 5 on a number line, what you're going to do on the My Math Lab is you're going to take this dot and you're going to pull it over to 4. So that's going to be how we get to 4. And then we're going to pull it on over 5 more places. Now mine's just on the screen. It's not interactive. But what we're going to do is we're going to count over to 4. 1, 2, 3, 4. And then I'm going to count 5 more places. 1, 2, 3, 4, 5. And I would be at 9. And that's how you would show students how to add on the number line. Okay, we'll move on to subtraction. Just like addition, subtraction has its own names, and I do use difference a lot in my classes here at Northwest, but minuend and subtrahend I have not seen since I was in the elementary school, but I do remember learning those a long time ago. But your top number is your minuend, and you're subtracting the subtrahend, and the difference is what's going to be important. The difference is what's left behind. Okay, so that's one of the things they can ask you definition-wise. The other thing they might ask you is, if you read through your textbook, they have different types of problems as they relate to subtraction. So the first one, an example of a takeaway method is if Joe had 8 and he spent 3. In other words, he took away 3. How much does he have left? So that's an example of the takeaway method. Okay, missing addend. If Joe has 8 chapters in his book, but he read 3, so it gave you the total. He read 3, how many does he have left? So we can think about it this way. He read 3, how many does he have left? So that's what's called the missing addend. You're taking subtraction and reversing it in your mind to addition. What plus 3 would give me the 8 total chapters there? Okay, so then you've got your number line method, which is the measurement method. If he walked 5 miles before lunch, okay, so here we are. He walked 7 total miles. He walked 5 miles before lunch. How many did he walk after lunch? Okay, so that's the number line method. And lastly, you have comparison. Joe has $6. Jay has $4. How many more does Joe have than Jay? And so that's comparing 2 different quantities, and that's the comparison method. Okay, so they're going to ask you a couple of those in your quiz this week, and just ask you, it's not going to ask you the answer's 5, it's going to ask you which method did they use.